Hi everybody, Ms. Swantek here. I'm going to be showing you how to determine the blood type of an unknown blood sample. So what we have here are 4 unknown blood samples. This is synthetic blood, it's not real blood. And we have 3 different antibodies. This is the anti-A antibody, this is the anti-B antibody, and this is the anti-RH antibody. So we're going to be using these man-made antibodies to determine what antigens are present on the surface of these 4 samples of red blood cells. When we understand what's called the antigen-antibody reaction, we can use that knowledge to determine an unknown blood type. So let's look at this picture. So in this picture, we have red blood cells with their antigens on the surface, and we have antibodies. Okay, so let's say that we didn't know what antigens were present on the surface of this red blood cell. What we can do is use antibodies to tell us what antigens are present on the surface of the red blood cells. When we look at the antibody, we see that it has 2 active sites. This means that one antibody can connect 2 red blood cells. So, when we add the antibody to red blood cells with unknown antigens, if the antibody's active site shape matches or complements or mirrors the shape of the antigen on the red blood cell, the antibodies will cause the red blood cells to form a clump. That is because each of the antibodies has 2 active sites and can grab onto 2 red blood cells at the same time. So what we see is what's called an agglutination reaction. Agglutination means clumping together. Okay, so we can use that knowledge. If we know the antibody we're adding, we don't know the antigens on the surface of the red blood cells, we can use that antibody and our knowledge of what's called the antigen-antibody reaction to determine the blood type. Okay, so we have our 4 samples and we have our antibodies. So we're going to go through these samples one at a time and determine their blood type. Okay, so we're going to start off so we're going to be using these trays, and the space in the trays are called wells. You can see it says A there, B there, and RH there. Okay, so I'm going to take sample 1. Going to shake it up because I want my blood to be a nice homogeneous mixture. Okay, and I'm going to put 1 drop of blood in each of the wells. Okay, then to the well that's labeled A, I'm going to add my anti-A antibody. And to the well that's labeled B, I'm going to add my anti-B antibody. So also you can see that these are colored blue, yellow, and then the last antibody on our bottle, it's labeled, hard to see this one because it's white, anti-D. This is the anti-RH antibody. So I'm going to add that to the 3rd well that says RH. Okay, now I want to give this some time for the agglutination reaction to happen. And I'm also going to help the agglutination reaction by mixing my blood with my antibody. Okay, so I have different colored toothpicks to make sure that I don't accidentally cross-contaminate my blood samples. So I'm going to mix this, and what I'm looking for is if I can see some clumping of the red blood cells. Okay, so I'm going to mix that. Okay, now I'm going to mix my blood with my anti-B antibody. Not seeing anything happening there. Looks pretty homogeneous. And then I'm going to mix with my RH. Okay, now I'm seeing maybe a little bit of lumpiness. Okay, I'm going to let this sit for another minute and then we'll look at it closely. Okay, so here's my result with my sample 1. Okay, so I can see agglutination, so I see clumping of the red blood cells with my anti-A antibody. I don't see any agglutination with my anti-B antibody, and with my anti-RH antibody, I see all these lumps. Okay, so that is my indication of agglutination. So sample 1's blood type is A positive. Okay, so the interaction of the anti-A antibodies with the antigens on the surface of the red blood cells cause this clumping. That tells me that the A antigen is present. And when I added the anti-RH antibody, I see clumping. That tells me that the RH antigen is present. Okay, let's do our next one. This is going to be sample 4. Got my tray. Whoops. Don't want to drop blood all over your carpet. That's for a forensics class. Okay, so I have my 1 drop of blood, and I'm going to add my anti-A antibody to the well-labeled A. I'm going to add my anti-B antibody to my well-labeled B. And I'm going to add my anti-RH antibody to my well-labeled RH. Okay, so what I'm looking for is, do my known antibodies react with my unknown antigens? Can I use the antibodies to tell me what antigens are present through their agglutination with the antigens on the surface of the red blood cells? Okay, I'm going to mix these. Try not to splatter it around too much like I did. Okay, I'm going to give that just a minute. I'm going to pause the video. Okay, give it another little mix. I don't have any clumping there with the RH antibody. See some obvious agglutination with my anti-B antibody, and I don't see any agglutination with my anti-A antibody. I'm going to try to zoom into that B well, if I can get my resolution good enough. Kind of spread that. You can see that agglutination. You see those darker dots? That is the agglutination. Okay, so if I have no agglutination with the anti-A antibody, I have agglutination with the anti-B antibody, and no agglutination with the anti-RH antibody, this tells me this blood type is B negative. This blood type is B negative. Okay, next sample. Okay, this is sample 5. I'm going to add my 1 drop of blood to each well. I'm going to add my anti-A antibody to the A well. Anti-B antibody to the B well. And anti-RH antibody to the RH well. Okay, give that some time to agglutinate. I'm going to mix my samples. Okay, I'm going to let that sit for a minute. I'm going to pause the video and come back in about a minute. Okay, so I've let this sit for a minute and I've mixed it so that we can see the agglutination. Okay, so when we look at our sample with our anti-A antibody, we see agglutination. When we look at our sample with our anti-B antibody, we see agglutination. Drag that around so you can see. Okay, we see that clumping. That's the agglutination. And with the anti-RH, oh boy, that's thick. Okay, so look at all that clumping. All right, so if we see agglutination with all three of our antibodies, that tells us the A antigen is present on the surface of the red blood cell, the B antigen is present on the surface of the red blood cell, and the RH antigen is present. So this blood type would be AB positive. Okay, last sample that we're going to look at. Okay, this is sample number 8. One drop of blood. Anti-A antibody. Anti-B antibody. And anti-RH antibody. Okay, I'm going to mix those and let them sit for a minute. We'll get our results. Okay, after letting these sit for a minute and mixing them, I see that things are looking pretty homogeneous. I don't observe any agglutination or clumping with any of these antibodies. Okay, so that tells me that this blood type is O negative. So the A antigen is not present, the B antigen is not present, and the anti-RH is not present. So all three antigens are absent, so that would make this blood type O negative.